All right, all. My name is Matt Barbour. I actually wear a couple of hats in the organization. I am the development manager for the Copilot Studio. Actually, I should say that differently. I am the development manager for the Microsoft 365 Agents SDK, and I'm also one of the architects responsible for the pro developer ecosystem for the Power Platform. So those of you that have seen me around the SDK for Power Platform, I've had a lot of influence in there and that sort of thing. They've brought me over to the Copilot Studio side to help build the Microsoft 365 Agents SDK. This is something we've been doing for a while. We talked a little bit about it at Ignite. And then we have now released it for general use in 3 languages. Right now, the first language is the first and most complete language is .NET, which is what I'm going to show today. It's also my home language. But we also have our JavaScript implementation and our Python implementation literally on the heels of this walking out the door. JavaScript has actually got a couple of internal partners that are actively using it. And the Python implementation, surprisingly to me, has a lot of interest and a lot of folks coming in. So we're finishing off some stuff in the user authorization layer, and then we'll be making that freely available out on PyPy. Now, so what I'm going to do is I'm going to start flipping through this. There's a bit of information about this as we move through. This is a little different than what we're going to show from the point of view of Copilot Studio. In the Power Platform and on the Power Platform ecosystem, we typically talk specifically about low-code or no-code solutions. The Microsoft 365 Agents SDK is actually completely the opposite. It is a pure code solution. It is all about development. It is all about building an agent your way and working with it your way. It is something that is designed to enable the ecosystem to come together. So the Azure AI Foundry feature sets, the OpenAI feature sets, Google's, Amazon's, and on to allow us to integrate them together and then surface them within the Microsoft ecosystem and then expose them wherever they need to be exposed within the ecosystem. So it's focused on a set of core capabilities and core features. So first off, I'm going to go through a little bit of marketing slides and we'll actually get into the cool stuff. The way in which we organize an agent as we develop, and this is consistent throughout the entire ecosystem at Microsoft. So the AI Foundry agent infrastructure is built this way. The Copilot Studio infrastructure is built this way. The M365 self-hosted or bot-hosted infrastructure is built this way, where we have this concept of a user experience that's an optional layer. We think of these as clients. On top of that or underneath that, we have an orchestrator. The orchestrator's job is to take the prompt and the other information that you have, create a plan based on knowledge sources and tools, and then execute that plan to return data to you. You saw that in just the previous demo here where there was a question asked. The knowledge source that was used in this case was AI search. It in turn parsed that, interacted with a couple of LLMs, and in turn returned you a result. Okay, this takes the form of lots of different things. You can have a single turn operation. A lot of APIs work this way, where you take something like Semantic Kernel and slap it into a function and have it just return an API call, single turn transaction. And then there are multi-turn transactions, where there is the scenario where I have to ask for clarification, or the orchestrator needs to clarify something along the way in order for it to feel that it has properly answered your question. Okay, so we're going to move on. And we're going to talk a little bit about what the Agent SDK brings to this picture. Now, the Agent SDK essentially encompasses that whole infrastructure, providing a couple of core capabilities to anyone that's building agents. We provide authentication support. Now, by authentication support, that means that a client can acquire an authentication token from a user and provide that to the agent. So you can act as the agent. Now, this is super important when interacting with M365. It's very important when interacting with Copilot Studio and a lot of other Microsoft technologies where, while yes, you can use service principals, you can act as a service. At the end of the day, if you actually can act as the user, you have more capability and you have the ability to act on behalf of the user. The second thing that we provide in the Agent SDK is conversation management or session management or thread management, depending on which technology stack you're coming from. At the end of the day, what this is describing is the collective set of transactions that are wrapped around a given conversation interaction event with a customer that could be spread across multiple nodes within your agent platform. Most demos that you see show just a little snippet of code, but when you actually need to turn that into reality, that becomes a hosted service or a shared service. There's multiple nodes with a load balancer that sits behind it. There has to be a way that the agents themselves can share state amongst themselves so that a request being processed by one agent can be easily processed by another copy of that agent within the same cluster. The conversation management infrastructure we provide gives you that capability. And then channel adapters. So those of you that have been around our ecosystem for a while know that we have a common protocol that we use for communication between pretty much all of our agents inside the Microsoft ecosystem, which is called the activity protocol. The activity protocol is our internal language. It's our agent-to-agent language. It's our internal communication. And actually, we make it available publicly. It's spec'd and documented publicly. And we surface that through a set of channel adapters. So if we need to talk to Slack, which has its own language, or we need to talk to Discord, or we need to talk to someone else's technology stack, we have the means to take that and translate that while managing the conversation aspects, the authentication aspects, and then handing it back to the orchestrator that you've brought to the ecosystem. So what does this look like a little bit more pictorially? Organizationally, you can see this as a set of tiers. At the very top of this experience here, you have a set of channels. So in this case, I'm surfacing M365 Web Chat, Slack, or other channels hosted through the Azure Bot Service. Now, the Azure Bot Service acts as our persistent channel broker. You can think of this like Microsoft Service Bus or Event Grid or something of the nature where you're standing up an endpoint that the downstream clients can communicate with consistently and store and forward those events out to your nodes, your Agent SDK nodes within your infrastructure. The Agent SDK at that point wraps around a set of orchestrator services or AI services or other such services, making the conversation state, the authentication tokens and whatnot available to you. The Agent SDK also has the ability to directly communicate with Copilot Studio. We'll see that in a later demo, not today, but in a later demo. And Copilot Studio has the ability to directly talk to Agent SDK nodes running around. Those folks that were asking about the Agents tab, you'll see an M365 Agent SDK in there. That's the capability where the Copilot Studio can communicate directly with Agent SDK hosted agents. After they can talk to each other, and they can talk to other clients who implement the activity protocol easily. Now, this is all wrapped around and working with what we now call the Microsoft 365 Agents Toolkit. Now, the Agents Toolkit is available in Visual Studio, which is what we're going to see today. It's also available in Visual Studio Code. The .NET implementation currently only shows up in Visual Studio. That is something we are working to change. We will hopefully have the .NET implementation showing up through VS Code sometime in the fall. That's the plan. We'll see how it works out. And inside the VS Code experience, we of course have JavaScript and Python. Okay, so I think I've gotten through all of the architecture, position setting slides. Awesome. Let's actually go look at code. So give me just a moment. Let me shift gears. And let's look at code. All right. So can folks see the code? Everybody see the screen? Just double checking.
Okay.
Yes. Awesome. Okay. So what I'm looking at right here is Visual Studio. I have a Visual Studio project that I've selected. In this case, I'm choosing the Microsoft 365 Agents project type, which then brings me into my typical project development experience. I'm going to just go ahead and click Create. And I get to choose a set of different kinds of agents. Now, the Agents Toolkit, the Microsoft 365 Agents Toolkit has a bunch of different functions. We've aggregated a bunch of agent-related things together. So the ability to build a function service is here. The ability to build a message extension for Teams, which could be used as part of an agent, is here. The ability to build standalone agents is here. The ability to create declarative agents for the M365 ecosystem is here. Those folks that want to create agents for the declarative agent structure for Copilot Studio, right now you've got to use the extension that we've shipped separately called the Copilot Studio VS Toolkit extension. And you can find that out on VS Code's extension marketplace. And that lets you do declarative stuff for Copilot Studio. The goal, of course, is to try to get this all aggregated into one thing. Schedules being what they are, we ship things a little independently just so that we can get things out the door more quickly. All right, so I'm going to start with something super primitive. As I scroll down here, I'm just going to start with your standard Echo agent. Now, whenever you're working with an Agent SDK, or whenever you're working with an agent that you're actually going to connect to the world, you have to think about something that way back in the old days, because I'm old, we used to call dial tone. For those of you that are too young to remember, what dial tone is when there used to be this handset thing that you'd pick a phone up and stick it to your ear, and there'd be a tone that indicated that there was power to the device and that it was connected to the network. We call that dial tone in the telco world. And the EchoBot wrapper is intended to support, yeah, there you go. The EchoBot wrapper is intended to support dial tone and initially act as a bootstrap to get your environment up and working. So I just started this project. I'm going to do nothing else, and I'm just going to click run. So I just click the start button. The project is going to go through the build process, and you're going to see a UX pop up here in a moment, a web page, which we call the M365 Playground. The M365 Playground is the new version of, those of you that have been around the bot framework, this is the new version of the bot framework emulator. This is a component that we've worked with the Teams organization, we work with the DevDiv organization, and we've made this now multi-channel. We've brought in, so we can simulate multiple channels. We've brought in authentication support for it. We've brought the telemetry and diagnostic capabilities into it that we had in bot framework. So we've improved that. So as you can see, it woke up, said hello and welcome. Hi there. And we've got an interplay working. No lights, no sound, no nothing. I didn't have to do anything. I've got a status stream rolling here in the background that's telling me what's going on, and I can communicate with my agent. Now, this is my basic lights on. I can communicate with my agent. That's neat. Doesn't really do anything except echo back. So now let's go, and I'm going to grab something I've already pulled apart. So what I have here is a sample that I borrowed from the Semantic Kernel team. Now, those of you that pay attention to models and new orchestrators that come out in the market often see companies come out and say, look how cool our model is. We can ask it a question and it'll give us a response. And you see a snippet of code that generally looks like, something like that. And that is the extent of the snippet of code that you see. Okay. When you roll back and you actually then go look at that project to see what's going on in that project, you then end up seeing things like, okay, well, there's this prompt that you gave it. Sometimes they show you that in a file and they're importing it from a file. And then you see that there's a set of plugins over here. In this case, there's a forecast plugin that's communicating up to, in this case, open weather to get real data back. And then you eventually run into a program. Now, you're going to see this in JavaScript, Python, the whole 9 yards. You'll always see this kind of wrapper around that basic sample. But this, at the end of the day, as I hit F5, is a demonstrator that opens up a console that invokes Semantic Kernel, communicating with Azure OpenAI, and using OpenWeather to answer a question. So simple, straightforward question. Okay, what's the weather in Seattle? You can see that it's giving me a little bit of status update. It's coming back saying, that's cool. I'm going to get the current weather, and here's the result. So how did it say looking for the current weather and fetching data back to my console? If we hop back over to our weather plugin, we can see there's a console write line. Well, that's awesome. It's writing to the console. Not super useful if I now want to make this available through, say, my own web chat or Teams or something else. Okay. But it gets me started. So let's also talk about the way it's returning. Now, right now it's returning data as just a text block. Okay, that's kind of cool. Now, one of the things that a lot of folks don't realize is that OpenAI and many others can actually speak adaptive card. You don't have to provide an adaptive card for that. You can just ask it to render it as an adaptive card. So here I've got two prompts. I modified this prompt to actually tell it to return it as an adaptive card And when it returned it as an adaptive card, give me this link. And I've got a little handy dandy little switch here to turn it on. True. So I don't have to copy and paste prompts around. And we're going to restart. And let me just actually clean that and restart it there so we don't see the ghost. There we go. What is the weather in Seattle? Same question. Okay. So again, there's our looking up, there's our fetching, and it splat out an adaptive card. I didn't tell it to do that. Semantic Kernel told it to do that. And OpenAI and the GTP4o model that this is sitting on generated that adaptive card. Now that's cool. That's awesome. Now let's actually turn it into something that I can use outside of my little demo experience. So I want to draw your attention to the agents, the plugins, and the program file. Okay. This process took me about 15 minutes to do. I'm not going to do it here on the call, but if anybody wants to actually see me do this at some point, I will actually do a YouTube video showing exactly how I took that and brought it in. So I took that semantic kernel example here with my program. Here's where I'm building my, here's where I'm instantiating my semantic kernel and adding the Azure OpenAI chat completion to it. Here's where I established my service collection. This is where I built my weather agent. I established my chat history. I wrote my initial console prompt, and then I invoked it. Okay, that's my original semantic kernel sample. I'm going to come over here to my Agents SDK, which started with EchoBot. I actually just used the EchoBot template. And in my program file, as you can see, I've now copied over, well, there's the instantiator for the Azure OpenAI instance, because I had to modify that just a bit because of the way that the agent works. The kernel is here. This is all boilerplate from the template. This is all boilerplate from the template. And if I come over to my EchoBot, inside my EchoBot, I've now added 2 route handlers. So now this is something that's the way that the Agent SDK operates. We operate on a concept called route handlers. The route handler concept essentially allows you to accept a request, create a filter on that request, on activity of type message, send it here. But I could say on activity where text is or where content has, and on and on and on. I have a complete capability to filter the various kinds of artifacts that are coming into my request and then route that to a message handler. Now, my message handler can also have sign-in handlers. I'm not going to show it to you in this time frame. I don't have enough time to dig into it completely, but we can actually pass in sign-in handlers to this that will allow us to land in that handler with a user access token that we could use. So here I've set up my route handlers. So when anybody joins this, send them a welcome message. And in the welcome message, I'm going to give that piece of text that we splat out on the console. Then anytime sends me a message, I'm going to drop in, build my service collection. I'm going to create my chat history. And because I want my chat history to be persisted for the conversation in case there's a clarification, I'm actually going to store that using the turn state, allowing me to store that in the background state. So create it or pull it from turn state. I then create my weather agent, just like I did before. And then I invoke my weather agent, just like I did before. The difference now happens here, where instead of writing this out to the console, we either send it back as text, or we send an error back as text, or we send the result back as text. Now, there's some stuff that's grayed out here. We'll see that in just a minute. Okay, so just to confirm, I'm going to pop over and expand my agents folder. There's my agent copied directly across. I'm going to drop down into my plugins folder. And I've modified this. You can see here that we passed in the turn context now. And I've modified this to actually send my status as a send activity. So I'm going to go ahead and hit start. Boot it up. Here's our playground again, just like we saw with our Echo agent. And there you can see right at the top, just like I saw in my console application, there's some text. I'm going to go, what is the weather in Seattle? And just like with my console, there's my 2 status updates and then my result. That's kind of cool. Let's actually now see this running in web chat. So this is the ABS, Azure Bot Service instance. I've refreshed it. There it is now. You can see the console in the background scrolling along just to prove that it's actually doing what I'm saying it's doing and it's not hiding off someplace else. Let's minimize this. And I say, what's the weather in Seattle? Off it goes. It's now communicating to my agent. There, I'm getting that same response. You know, let's go look at it in Teams. And there we go. Okay. 3 different channels, 3 different responses. Now, this isn't great because of the way this is working. I don't like the way that works. It's kind of ugly. So let's now take advantage of a scaling capability that we have in the Agents SDK that is channel aware. So I'm going to hit the stop button here. I'm going to go back to my Agents project, my actual Agents project here, and I'm going to enable this use streaming capability, okay? So when I use streaming capability, when I turn that on, you're going to see the big difference is those gray areas switched. And now I'm using turn context streaming response. Okay, again, this is a capability that's in the agent. I showed it to you one way. I wanted to show it to the other way because if I just show it to you using the streaming response, you actually can't really tell on the other end what it's doing. So here I'm going to restart it again. Because our Agents Playground is set up and designed to work with the Agents SDK, and in this case, it's acting as a streaming aware channel. If I say, now I have a different kind of experience happening. I have some text streaming, and then it drops down into this experience and shows me this. Now, again, I'm just showing that experience. If I pop over here and go back to my web chat experience and I ask the same question. Let's change it up. So weather in Dallas. Notice now we actually get a typing indicator. Why? Because the web chat component doesn't support streaming. The Agent SDK is aware of the capabilities of channels. And if the channel supports streaming, it will use streaming, and if it doesn't, it won't. Okay, so again, coming back into Teams, and I go back to this, and I ask it again. And once again, we're using streaming to do that response. Now, that's kind of cool. I'm going to show you one more channel that's kind of neat. I'm going to go on here, and here I am in Copilot Studio. I'm actually in the M365 experience here. I'm going to do @agent demo builder here, and I'm going to ask it a question in Dallas. And here again, we have that same streaming response capability now surfacing through this area. How did I do this? How did I actually make all of that work? What's the secret sauce rolling in the background? Again, coming back to the diagram I showed you a moment ago, the Agent SDK is routing things through the Azure Bot Service, which is acting as our channel manager in this case. So the Agent SDK client itself is channel aware and communicating to the agent, communicating to the upstream clients through ABS. ABS is what is advertised those endpoints to those clients, which means that I have got 3 different client registrations pointing at the same endpoint with 3 different channels, which in turn allow the Agent SDK to react appropriately to whichever channel it's communicating with through this one endpoint. How am I doing this on the dev? Running this on my dev workstation? We're using a dev tunnel, and we're communicating through dev tunnels, which is a capability that is provided by the Agents Toolkit. It's also stuff that you can use outside the Agents Toolkit. So for any given request, I can actually see what was sent in and what that communication was, as well as any headers with authentication tokens and any response that it sent back to those particular requests. Okay, this is the Agents SDK. This is the introductory to it. As far as where to go to get started, to start playing with this, you can get started with this by 2 places. You can either go over to GitHub. By the way, this is all open source. We don't charge for this. I want to be very clear. We actually don't charge for the Agent SDK. The Agent SDK is free to use. However, you do have to pay for the downstream services. So anybody's service that you're using, you do have to pay for. Those are licensed. You can get the source code or get started at the Microsoft Agents SDK. You can find the packages on NuGet, NPM, and right now TestPy. And if you want to start at our Learn site, that is it right there. Just search for Microsoft 365 Agents SDK, and you'll land on our Learn site.